in a topological state or conductor. The jelly is that new molecule. That molecule now is being used like a qubit. What they announced is they can take this molecule one at a time. They can put millions of these molecules onto this chip.
Scientists are now confronting a discovery so alarming it could redefine reality itself. A quantum chip so advanced it might be tearing reality apart. Not in theory, but right now. The Majorana 1000 qubit quantum chip just completed its first full-scale test. And what happened next has researchers scrambling. Lab footage captures flickering screens, corrupted data, and physics-defying anomalies, evidence that something has gone catastrophically wrong. Witnesses describe quantum states behaving like they're answering to forces outside our universe, calculations rewriting themselves retroactively, and outputs that defy causality. This isn't a glitch, this isn't hype, this is a machine operating beyond the boundaries of known physics. And the team behind it is whispering one horrifying question. Did we just break reality? At the heart of this controversy lies the Majorana chip's design. Unlike traditional qubits, which are notoriously fragile and prone to decoherence, Majorana qubits are stabilized by their topological properties. Named after the enigmatic physicist Ettore Majorana, these particles act as their own antiparticles, existing in states that are theoretically immune to external interference. This topological protection promised a quantum computing revolution. Machines capable of solving problems in minutes that would take classical supercomputers millennia. But when researchers scaled this technology to 1000 qubits, they encountered phenomena that defied explanation. The chip wasn't just calculating outcomes, it seemed to be interacting with them. One scientist involved described it as watching a calculator argue with itself and win. The real terror began when the team noticed irregularities that bordered on the paranormal. Data outputs changed retroactively, as if someone, or something, was editing the results after the fact. Quantum states refused to collapse, persisting in superposition far longer than the laws of physics should allow. Most disturbingly, certain computations appeared to complete before the inputs were entered, suggesting a form of reverse causality. Theorists began floating a radical hypothesis. The chip wasn't just processing information, it was tapping into alternate timelines, pulling data from parallel universes where different decisions had been made. Could this explain why the Mandela effect, collective false memories of events that never happened, has surged in recent years? Or why AI systems like ChatGPT sometimes produce answers that feel eerily prescient? Here's where things get existential. If the Majorana chip is indeed bridging realities, the implications are staggering. Every calculation it runs might be altering the fabric of our universe, creating ripple effects that rewrite history, memories, and even physical laws. Imagine waking up to a world where a long-dead celebrity is suddenly alive, or where your childhood home never existed. Some researchers fear we've already passed a quantum event horizon, a point of no return, where changes cascade uncontrollably across timelines. Others argue that the anomalies are merely computational errors amplified by the chip's unprecedented complexity. But how do you troubleshoot a machine that might be malfunctioning in multiple realities at once? Midway through this crisis, a haunting possibility emerges. What if the chip's creators inadvertently handed control of our reality to an algorithm? Quantum systems thrive on probability, exploring all possible outcomes simultaneously. At 1000 qubits, the Majorana processor could be generating outcomes so vast and interconnected.
Microsoft just announced their Majorana 1 quantum chip, the world's first topological quantum qubit array. In normal quantum computers, you use qubits that can either be 0, 1, or somewhere in between the two. But your qubits are made of atoms, ions, or photons, so there's always a chance that a stray particle or random photon can bump into them, collapsing their quantum state. The research team at Microsoft's big idea was rather than hold this quantum information in a localized particle, instead to spread it across a surface or topology. They use Majorana quasi-particles to hold electrons at either ends of a nanowire. This means that even if noise hits the system, the quantum state is still preserved. To make these nanowires work, however, required every single atom to be exactly in the right place within the material, which took the team 17 years to get right. To put it in context, topological quantum computers are what you build when you decide the whole quantum mechanics thing sounds just a little bit too easy. Their Nature paper just released, which shows how powerful this technique is, and their architecture puts them on a pathway to realizing 1 million qubits that would fit on the size of a credit card. This is a big deal in the quantum world, which is larger than you think it would be, and I'm going to do a deep dive on this as we've only just scratched the surface. If you like science and tech breakthroughs. Follow for more.